Okay, so I'm going to try and demonstrate to you a practical experiment called Young's double slits, named after a bloke called Young who did loads of really cool physics. And this experiment uses two slits, as the name suggests, and this is really an amazing experiment, and you've got to do it yourself to really appreciate it, but I want to take you through it with this video first. If you're in my class, then you're going to do it next lesson yourself. We've got enough for you to do this experiment in pairs. So what does it involve? It involves this, which is a spirit level that's got a laser in it. So if I point that at the wall there, hopefully you can see it's a red laser. It's a nice low power laser that's going to be safe for us to use. Young did this hundreds of years ago, so he didn't have lasers, but they make our life easier, as you will see. We've got this thing here, which is a collection of double slits. So if you look really closely, you can probably see 4 slits in this slide. If I hold it up to maybe a white background, you see it more clearly. Each of those things that you can see there, oh no, that's lovely, that's focused really nicely. So you can see that each of those things that looked like one slit is actually a pair of slits. And the ones on the right are quite far apart, and the ones on the left are really close together. So these are double slits. What happens when the light passes through these two slits is that it spreads out. So when light passes through a narrow gap, it spreads out, it diffracts. And then the light coming from each of those two slits can interfere. So I'm going to shine the laser light through. I'm going to use the leftmost pair of slits because that's going to work best. So I'm going to shine this laser through a double slit, and then all the way over there, I'm not sure if you can see it, is a screen. It's a long way away, and you'll find out why that is shortly. So, here we go. I'm going to turn the lights off. I'm going to turn the laser on, and I'm going to direct the laser through 2 of the slits. So the laser light is going through a double slit, 2 slits very close to each other. All the way down there on the screen you might just see some red. Now, actually, let me show you what it looks like without the double slit. Without the double slit, it looks like a dot. Okay, let's go back. Now, I've put a double slit in the way. So the laser light is passing through both of those slits, it's spreading out, it's diffracting, but when it gets over here, you get this very interesting pattern of bright and dark fringes. So it goes bright, then dark, then bright, then dark, then bright, then dark, and so on. So this is a 2-slit interference pattern of light. Now, if you're in my class, we've already done this with other things. We've done this with sound. So we had 2 sources of sound, same frequency, playing the same pitch, and we walked past them, and we noticed that in some places the sound was loud, and in some places it was really quiet. I also tried to demonstrate it with ripples on a pond. The Veritasium video has got a really good video of that, where you can clearly see some bits where the water ripples are bigger and some places where the water ripples are smaller. So here it is. This is the 2-slit diffraction pattern that Young observed. Now, often in textbooks you will see, you might see a photo of it like this, but often you will see this represented graphically as an intensity plot. So if I take the middle of it down here, I'll do my best to draw straight. So this is roughly the middle of the pattern, and you'll see that I've already drawn a line on here on the x-axis. What we can do is sort of plot the intensity, sort of plot the brightness of the light as a graph. So here the brightness is very bright, and then a bit further along, so in the middle it's very bright, a bit further along it's very dark, a bit further along it's bright. It's not as bright as it was before though, maybe it's there. Then we've got no brightness. Then, well, it's dimmer than it was before, something like that. Then no brightness. Then it's even a little bit dimmer. So we're getting this pattern, and if I try and mimic that pattern, the pattern should be pretty much symmetrical. Then we could try and join that up. Let me turn the lights on. So now we've done that, we can take the screen off now. So now, what we've got, let me zoom you in a little bit, is we've got an intensity plot which looks like a mess, but don't worry, we'll sort it out. So here it was bright, and then it went dim. So we've got a lot of brightness, then no brightness. Then a bit that was a bit dimmer, then it was dark. Then it was a bit dimmer, then it was dark. Should be roughly symmetrical. Good. So this is an intensity plot where the x-axis is like, excuse me, that is distance from the centre of the screen. Distance from the centre of the screen. The y-axis is like light intensity. So you need to know what this intensity plot looks like for the Young's double slit experiment. You also need to know what it looks like for a single slit too, but we'll do that afterwards. Now, the spacing between two of these fringes, the spacing between the middle of this bright one and the middle of this bright one here, that's called the fringe separation. So the distance from one bright fringe to the next bright fringe is called the fringe separation. However, instead of just doing it between one fringe like that, you're better off measuring between like 10 fringes or something like that. And actually, if you look, if you rewind the video and have a look at those fringes again, you'll notice that the bright bits are quite wide and the dark bits actually seem to be quite narrow. So you're actually better off measuring between the minima, between the dark bits. So if I draw on here, here's one dark bit, 1, 2, 3, 4, maybe doing 5 of them or something like that. So measure 1, 2, 3, 4. I didn't quite get 5 though, so I'd have to do 4. 1, 2, 3, 4. I'd be better off measuring that distance there and dividing by 4 to get my fringe separation. So that was just to really demonstrate how the practical works. It's very straightforward when you're using a laser, it's really easy. How it works, what the pattern looks like, and how you might see that represented in a textbook as an intensity plot like this. Next lesson you're going to do the experiment, you're going to do some measurements, and by looking at the formula we're going to be able to deduce the wavelength of the laser we are using.